Dear students, today we're going to talk about matter. Let's take a look at the objectives of our lesson, then we'll start. What is matter? Matter is everything that has mass and occupies space. Before starting, let's check your prior knowledge. Which one of these is not matter? Water, air in a balloon, sound, or keys? If your answer is sound, you're correct. Each of keys, water, and air in the balloon has mass and occupies space. Sound, light, and fire don't have mass and they don't occupy space, so they are not matter. Matter exists under three physical states: solid, liquid, and gas. Let's describe matter by its shape. Ready for the first activity? In this bottle, we have water colored with food coloring. Let's draw the shape of water when it's in the bottle. Right now, I'll transfer the same water to a cylindrical container. Does water keep its shape? No. Right now, the shape of the same water is cylindrical. What will happen if I transfer the same water to another container, which has a rectangular prism shape? Water will take the shape of the container. So, liquids such as water don't have a definite shape. They take the shape of their containers. Similarly, if I transfer the gas from one balloon to another, gas will take the shape of the balloon. Look at the gas taking the shape of these balloons. So, gases don't have a definite shape. They take the shape of their containers. What about solid? In front of me, this book, which has a rectangular prism shape. If I'll move it to another room, does the shape change into cylindrical? No, solids have a definite shape. To sum up, a solid has a definite shape, while liquids and gases have an indefinite shape. They take the shape of their containers. A key occupies a small space, so I'm able to put it in my wallet, while this balloon occupies a large space, so it doesn't fit in my wallet. What am I talking about? I'm talking about volume. So what is volume? Volume is the amount of space needed by an object. How to measure the volume of a liquid? The volume of a liquid is measured by using a tool called graduated cylinder. In order to know the volume of water, you'll just put it in a graduated cylinder. Look at the top surface of water. It has the shape of a curve. This curve is called meniscus. To read the volume of water, we have to look at the bottom of the meniscus. It is extremely important to read the volume with a proper eye level. It makes a big difference. To read the volume properly, the eye level must be at the level of the meniscus. Otherwise, the value of the volume will be incorrect. What's the volume shown in this graduated cylinder? Example 1. The volume of water is between 6 and 8 milliliters. To know the exact value, I'll subtract 8 minus 6, so I'll get 2 milliliters. As there are 10 divisions between these two values, I'll divide these 2 milliliters by 10, so I'll get 0.2. Accordingly, each division stands for 0.2 milliliters. From 6, I'll start adding 0.2 for each division, so I'll have 6.2, 6.4, 6.6, 6.8, 7, 7.2, 7.4, 7.6. And then the volume of water in this graduated cylinder is 7.6 milliliters. Example 2. The volume of water is between 4 and 5 milliliters. To know the exact volume, I'll subtract 5 minus 4, so I'll get 1 milliliter. As there are 10 divisions between these two values, I'll divide this 1 milliliter by 10. So I'll get 0.1. Accordingly, each division stands for 0.1 milliliter. From 4, I'll start adding 0.1 for each division. So I'll have 4.1, 4.2, 4.3. And then the volume of water in this graduated cylinder is 4.3 milliliters. Milliliters is suitable for small volumes, but when it comes for the international unit, volume is measured in cubic meters. Each cubic meter equals 1 million milliliters, or 10 to the power 6 milliliters. Accordingly, in order to convert from cubic meter to milliliter, we'll multiply by 10 to the power 6. Oppositely, to convert from milliliter to cubic meter, we'll divide by 10 to the power 6. Let's practice. A sample of water has a volume measured by a measuring cylinder as 25 milliliters. What is the volume of water in cubic meter? Already we know that 1 cubic meter is equal to 10 to the power 6 milliliters. To convert from milliliter to cubic meter, we'll divide by 10 to the power 6. 25 is 25.0, so I have to move the point 6 digits back. From this point, I'll go back for 1, 2, 3, 4, 5, 6 digits, and then the answer is 0.000025 cubic meter. Example 2. A sample of water has a volume of 0.050 cubic meter. What will be the volume of the water measured in a measuring cylinder in milliliters? As we arranged, 1 cubic meter is equal to 10 to the power 6 milliliters. To convert from cubic meter to milliliters, we'll multiply by 10 to the power 6. So I have to move the point 6 digits forward. 1, 2, 3. And still I have to add 3 zeros, so the answer will be 50,000 milliliters. Mass is the amount of matter in an object. Mass is measured by using a digital balance in grams. As I'm adding more pieces, the amount of matter is increasing, and then the balance is showing a heavier mass. Larger objects always have a greater mass. Do you agree? Previously, we discovered that the key occupies a small space, and then I'm able to put it in my wallet, while the balloon occupies a larger space, so it doesn't fit in my wallet. Accordingly, the balloon has a larger volume. Does it have a heavier mass? In order to know, I have to measure the mass of each by using a balance. Then I'll compare. It's clear that the mass of the balloon, which is the larger, is 1.5 grams, while the mass of the key, which is the smaller, is 14.1 grams. Accordingly, a larger object never means the heavier. From this experiment, we learned that a bag of cotton, which occupies a large volume, isn't heavier than the iron, which occupies a small volume. The brick and the sponge have the same volume. Do you think that they have the same mass? The needle of the balance shows clearly that the brick is heavier. The unit gram is suitable for light objects, but when it comes for the international unit, mass is measured in kilograms, where 1 kilogram contains 10 to the power 3 grams. Accordingly, In order to convert from kilograms to grams, we'll multiply by 10 to the power 3. Oppositely, in order to convert from grams to kilograms, we divide by 10 to the power 3. Let's practice. A sample of water has a mass of 500 grams. What is the mass of water in kilograms? In order to convert from grams to kilograms, we divide by 10 to the power 3. Accordingly, we have to move the point 3 digits backward, and then the answer will be 0.5 kilograms. Example 2. A sample of water has a mass of 1.6 kilograms. What is the mass of water in grams? In order to convert from kilograms to grams, we multiply by 10 to the power 3. Accordingly, we have to move the point 3 digits forward. So, the point is moved for 1 digit, and still I need to add 2 zeros, and then the answer is 1,600 grams.